Geometry, Lesson 7.3. In this section, we're going to expand on the P-theorem. Let's review the theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. We're more familiar with this as a squared plus b squared equals c squared. This picture that I have here is just one example of a proof of the P-theorem, and this is what they call a perfect triple. It's a P-theorem with primes, and we see that we have a leg of 3, a leg of 4, and a hypotenuse of 5. And the way that they prove that is to align these squares next to them, and if you see that each square is the length of the leg or the length of the hypotenuse squared. So 3 squared is 9 squares, 5 squared is 25 squares, 4 squared is 16 squares. Let's take a look at example 1 in your book. We're going to find the lengths of the legs of the right triangle. In this instance, what we have is a right triangle, hypotenuse of 17, leg of x, and another leg of x plus 7. We're going to apply the P-theorem and simplify the resulting equation. So this is the equation, a squared plus b squared equals c squared. And you need to fill in your values. So we have the first leg, the second leg, and it's being placed equal to 17 squared, the hypotenuse squared. Now, in this problem, we have a situation because we have x plus 7 squared. That means we're going to need to use FOIL. And if you don't remember FOIL, that's first, outside, inside, lasts. And you may need to review your FOIL. You can do this on Khan Academy or Math is Fun. If we go ahead and distribute the parentheses, we have the first x squared, then we end up with x squared plus 14x plus 49, and 17 squared is 289. If we normally in the next step, what we would do is subtract 49 from the 289, and we would end up with 2x squared plus 14 squared equals 240. However, you need to be aware of the pattern of this equation. This is a quadratic equation, and what we're going to do is set it to 0. So that 240, which was positive, we're going to now bring it over to the left, make it negative, equal it to 0, and then we're going to look for any like items that we can reduce this by, and we can divide each one of the terms by 2. So we end up with x squared plus 7x minus 120 equals 0. And now you'll have to find your factors. The factors will be x plus 15 times x minus 8. We set each one of those to 0, so x plus 15 equals 0. Its answer is negative 15. And x minus 8 equals 0. Its answer is 8. And as I showed you in the last video, we will only be using positive answers for the figures that we work with. So if x equals 8, x plus 7 equals 15. So these are going to take you a little longer than some of the other problems because you're going to have to review your factoring and your FOIL. Let's move on. And we have example 2. We have an equilateral triangle. find the area of the equilateral triangle. If you remember, let me get my pen out here. Equilateral triangles have 3 equal sides. So, what we'll need to do to work this problem is drop an altitude and create 2 congruent right triangles. So when we drop this altitude, Km, we form this point M, which will be the midpoint of segment JL. We're going to apply the P theorem then to one of the triangles. And we have a hypotenuse of 8, and we have a leg of 8. So all we have to do, scratch that. We have a leg that is half of 8. So that'll be 4. So what we have to do is go ahead and use the P theorem to solve. And we have height squared plus 4 squared equals 8 squared. Height squared equals 48. That is 64 minus 16. The square root of 48 equals the square root of 16 times 3, which is 4 radical 3 as an answer. And by the way, if you memorize this, your book uses this same number all the time. Now, because our height is 4 square root of 3, we can now solve for the area of a triangle, area being base times height. So now let's look at our base, and we know that we have a height of 4 square root of 3. So 1/2 the base, which is 8, times 4 square root of 3 will be 4 times 4 square root of 3, which is 16 square root of 3 centimeters squared, which is approximately 27.7 centimeters squared. By the way, when you do these problems, unless I tell you otherwise, I prefer that you keep them in the radical form. If you want to go ahead and solve it with your calculator, you can, but I want to see the radical form in there also. Let's move on. So, the converse of the P theorem. In the P theorem, it tells us, let's go back, in a right triangle. For the converse, it talks about the triangle being right at the end of the theorem. So what we do have here is a theorem that's reversed. If the sum of the squares of the lengths of the triangle equals the square of the length of the third side, then the triangle is a right triangle. So if you already have information that tells you that a squared plus b squared equals c squared, you have values in there and they equal, you know that it's a right triangle. Let's look at example 3. Determine whether a triangle with side lengths of 7, 12, and 13 is a right, acute, or obtuse triangle. So, we use the triangle inequality theorem to check that such a triangle exists. So, mixing these numbers around, we find that 7 plus 12 is greater than 13, so we really do have a triangle here. Now, let's find the length of the hypotenuse to see, and to set it equal to the shorter two lengths. So, c squared equals the 7 squared plus the 12 squared. And we work this out and we end up with approximately 13.9. Now in this situation, you wouldn't leave the radical because we're going to be comparing lengths of sides. So, it says here that note that the third side of the given triangle is shorter than the hypotenuse of a right triangle with legs of 7 and 12. So we just found the third side, and it's 13.9. The original third side was 13. It's shorter than the hypotenuse of a right triangle. So we have the answer for a right triangle is 13.9. The answer for a triangle is 13. They would have to be equal for this triangle. 7 plus 12 is greater than 13, or this triangle, sorry, 7 inches, 12 inches is 13, for it to be right. So it is not a right triangle. So the triangle is acute, because the angle opposite the 13-inch side must be acute. And that's the converse of the hinge theorem. So let's take a look at some pictures of this. If the longest side of the triangle were greater than square root of 193, the triangle would be obtuse. So we have a triangle here, a side of 7, a side of 12, and a hypotenuse of less than 13.9. That means that the angle opposite would be less than 90. Here is our right triangle, and that's what we solved for originally, and there's the answer right there, 13.9. And so we started with this as our baseline. This is what it has to be as a length to be right. Anything less than that will be acute. Anything more than that will be obtuse. Now I know that that is a little bit confusing, but if you have trouble doing these problems when it asks you, come back to the video or contact me and I'll help you. So we come to a corollary. A triangle with side lengths A, B, and C, where A is less than C, or less than or equal to C, and B is less than equal to C, is an acute triangle if C squared is less than A squared plus, and that should say, let me correct this right now, B squared. And is an obtuse triangle if C squared is greater than A squared plus B squared. All this corollary is saying is what we just covered here. So it's just repeating this information. Your homework is numbers 1 through 10, 12, 15, 20, 22 through 23, and 46. And let's take a look at the table that contains number 8. They're asking you to fill in the unknowns for a leg of a right triangle. You have leg and the hypotenuse. You have known values for one leg and the hypotenuse. So go ahead and solve for whatever you can. 3 squared is 9. 5 squared is 25. Continue to solve by subtracting 9 from both sides. A squared equals 16. And A equals the square root of 16, which is 4. So that means that the missing side length is 4. For number 12, a hint, write the values that are given inserted into the P theorem. So write out the P theorem here, A squared plus B squared equals C squared. Then they give you some numbers for number 12, put them in there, and then solve to the best of your ability. These problems will not solve down to numbers, whole numbers. So you want the equation to equal the missing leg. So an example would be, and in your book you can look at number 11, its answer is C equals the square root of x squared plus 25. And let me do something here. And what I've done is inserted a line here. In your symbols on your computer, it doesn't have a line over that square root. and I wanted to make sure you knew that that was square root of 25. Number 20, for a hint, use the P-theorem to find the length TA. So that's it for this lesson. Once again, you can refresh your algebra on Math is Fun or with Khan Academy. Call me if you have any problems. Text me or email me, and we'll talk to you soon.